Hey everyone, welcome to Bread and Code. Today we are going to solve a problem A painting with two colors of Codeforces round 145. First I will explain this problem, then I will show you my solution. So first go and read this problem, then I will explain. Okay, so here in this problem it says that we have given uh, three positive integers and A and B, and n is considered as the length of the cells considered in an array. Okay, and for the and we have to choose two different or same x or y such that we have to paint uh, red color for from index x to x plus a minus 1 of length a, color red, and blue of length b. So, and there is a case called coloring of the grid is called symmetric if and only if ith color uh, is equivalent to the n plus 1 minus ith colors, means the same index from the last. Okay, so we have to output uh, is there an exist any x and y such that the finally current color of the grid is symmetric, and there is also a condition when we have colored the cell red and blue, the final color is considered always blue. Okay, first just see how this array look like. 1 2 3 4 5 6 7, and it's equal to 7 here. Let's see, for this odd length, if we have some given b which is some even size, then for the symmetry we have to take this midpoint, and the color of this cell should be same to color of this cell, and color of uh, wait a second, color of this cell should be same to color of this cell, and color of this cell should be same to color of this cell uh, from this midpoint, and this color can be any color. So if my b is even, uh, means the final coloring of the cell is blue. So if we try to uh, color this cell, means if we try to choose some x and y, x for coloring red and y for coloring blue, then now think in this way, the parity of this blue color and index and a color parity, then what we observed that the nature of the b should always be equal to the nature of n, then we can color this array symmetry, uh, because blue color always exists in the final one, means the uh, our segment should be look like something this wait, let me take a blue color here, blue color like this, and taking symmetry. If you choose something y here for the blue of length b, then number of columns in the right side and left side should always will be equal, uh, and can be set in this n cell only if the parity will be of blue, means b and n are equal. Otherwise if n is even something like n is 4 and b is something like 1 or 3, then we can never uh, distribute evenly on left and right side from the median. That's why parity of blue and blue color size and the n size should be same. uh, there is also one condition. Think about this, how we can adjust the red color in this array. Pause this video and think again. Okay. uh, to add Now coming to the adjustment of the red color. First, we have already colored the array blue. Why we have colored the array blue? Because here mentioned a point that final color is always blue, and to have this to achieve this symmetry, we have to always, means the coloring of this median will always be blue. We can't never color this red. If we color this red, then we are, means we have chosen another uh, y and colored that other segment of either left or right segment of our array blue. Then we can never achieve symmetry because we always have to exclude that other path. That's why uh, we have taken blue first as a priority. Now coming to the color of the red cell. For the red cell, we can see the choosing some x. So if, let's take y have chosen something like this in the array, and coming to the x can be starting from the less than y or greater than y. What's what we have to choose? Let's see. uh, for the symmetry again, this is going to be the same case. We have to distribute from the midpoint, but here in the midpoint we have some advantage. We don't have to see the parity of a on a case when a size of a is less than equals to size of b, because we can choose that same x equals to y here, uh, because our array will be symmetry and we have colored this segment first with red color, and choosing the same y gives me the blue color. Means if a is less than equals to b, then if the b and n have same parity, then answer will always be possible. But if there is some case when a is greater than b, means we are going to exceed the uh, length of the b coloring. Some a color will be here, some a color will be here. So red color, uh, seeing this red color, again we have to think about the parity. Means the parity of the a should be same as parity of the n, to distribute them evenly on left and right side. So that's the whole solution of this problem. Coming to the solution I have submitted. First condition is that I have checked the parity of the n and b. If they are same, then we have that two different cases. If a size of a is greater than b, then we have to again check the parity of a and n that I have talked in the last. Then answer will be yes, otherwise no. If the size of a is less than equals to b, then we can choose the same x and y, that same x that we have chosen for the y, uh, because we don't have to see the parity, because size of a is less than equals to b, the final coloring will always be b, and the b parity is same as n, so answer will always be yes, otherwise answer is no. That's all for this problem. Thank you.